Hello everyone, we're going to talk about the Guix RISC-V Bootstrap and the effort we have been doing during the last years in this line. So first of all, my name is Ekaitz. I'm a freelance engineer located in the Basque Country. There's my website. You can enter into that and check what work I've been doing in the last years. Yeah, that's all. You can find me probably in the Guix mailing list. You can find me in the IRC. You can find me many places. I'm part of the SIG team. We are working on trying to make the new versions of SIG available in Guix. I also made the SIG build system for Guix and some other extra things you can find in the Guix history. But mostly the last years I've been working in the RISC-V Bootstrap system for Guix. So we're going to talk specifically about that. So what is RISC-V first? That's a very interesting question. We have to solve this, right? We have to understand what's RISC-V first, and then start thinking about the bootstrapping on it, right? So RISC-V is a processor architecture. It's what it is called an ISA, an instruction set architecture, right? So this instruction set architecture defines the instructions specifically of the processors that they are going to run our programs, right? As this computer I'm using right now, it's an x86 64, and we have like the mobile phones in general, they are ARM and stuff like that, right? So RISC-V is a new architecture. It was designed with the goal of adding some competition to this market, to this processor market, and it has very interesting ideas behind. First of all, most of ISAs in general, like the x86, ARM, and all these, they are proprietary and they have some license fees, and you have to pay if you want to design a processor that uses these architectures. And for each processor you sell, you have to pay some companies. In the case of ARM, they don't invent processors, they just define some ISAs, and some other companies, they create the processors and they have to pay the license fees for ARM because they invented the ISA they are using, right? So this is very normal in the processor architectures. We have just a few, the most common ones are just a few, and most of them are using this model, right? They are proprietary, and the ones that make the processors, they have to pay some license fees. The case of RISC-V is very different. RISC-V is an open architecture, meaning that the ISA is free to use. You can define new RISC-V processors using this ISA, and you can create them, and you don't have to pay license fees to anyone. And literally, it's like kind of an open source or free in the libre meaning ISA you can use. Okay. The other part that is very interesting in RISC-V that is very different from other architectures is that it is designed to be modular. Being modular means that the ISA, this specification of the instructions the processor has, is separated in several pieces. The first piece might be like the minimal part, then we have other pieces like the multiplication capabilities, they are a separate piece. You have the atomics, you have the, I don't know, there are several pieces. The floating point arithmetic is another piece you can add to your processor, and that way it allows the RISC-V implementers, the ones that are going to do the processors, right, the machines themselves, to decide which of the features of RISC-V they want to add. And this is super interesting because it's allowing the definitions of the processors to be from very simple machines to very complex machines and anything in between. So the target goal of the RISC-V architecture is to make from microcontrollers to huge servers and everything in between. You can make computers using this architecture, you can use microcontrollers, and of course you can use huge servers of 128 bits and these kind of things. There are extra modules for that, right? So the processor architecture is modular, and that's cool. That's very cool. So, and what's the status of Linux and RISC-V at the moment, right? So we can say we're getting there. It's most of the work is already done. You can run Debian in a RISC-V architecture. You can run it. It's perfectly okay. It basically Linux works mostly in some specific modules of RISC-V. There are some minimal things that the Linux needs, but that's mostly mostly the thing. We have compilers for it, like GCC has RISC-V support since the version 7.5. We can link against it. We can have assemblers. The GNU assembler works in RISC-V perfectly fine. Most of the programs can be compiled for RISC-V perfectly okay. Mainly the problem is that we don't have that many processors to choose from. We don't have many companies developing these processors yet. So in the end, the stability is not great because we don't have so many machines to test on. And in the end, some packages are not being ported because there's no need yet to have like an industrial complex working on this, right? Or all the programmers in the world working on this, because basically there are almost no machines for users, for end users to work with. We do have small microcontrollers. There are many working with RISC-V, and there are some other machines that might get in this point of, I don't know, mobile level computing power, but they are not many machines like home computers that might be running RISC-V in a powerful way, because there is no industry interest in that yet, or there is, but it didn't really develop to the point that x86 did, mostly because x86 for 64 bits have been running for many years, and RISC-V is a really modern architecture. It has like, I don't know, it's 15 years old, something like that, not that much, like comparing with other architectures that they were invented in the first version long ago. The path that they traveled, it was, in this case in RISC-V, is way shorter. So it's probably just that's the only issue we have. Mainly, the Linux support is okay. I already said we have several Linux distributions running on top of the RISC-V architecture, but in our case, in the case that is ours, right, the Guix case, we can say that Ephraim is doing a great job, and he ported many packages, and they are running in RISC-V, but we had some holes to fill. One of them was the bootstrapping, and we are getting there too. So yeah, the support is pretty much okay. If you have a small RISC-V machine, you can test it. I've been running Guix as a package manager in a RISC-V machine in a Vision 5, and it runs perfectly fine. What we don't have is proper releases for those, right? We have to make them. I had to hack some things, and Ephraim helped me to prepare them, and I don't think we have ready some I would say some binaries for those, but it's pretty much getting there, and it will be super well supported probably in the next few years. So what is the bootstrapping now? This is one of the problems that I want you to start thinking about, because mostly when I talk about the project we have been doing in the last years, nobody knows what bootstrapping problem is, right? And this is mostly my concern at this point, because in the end, the bootstrapping problem is a really important thing. It's a security issue we have, and I would like for more developers to pay attention to this problem, and also users, right? Because some of the most used Linux distributions are not using this kind of concept, or they are not being bootstrapped. So let's define a little bit what is the bootstrapping problem, but we're probably going to do it with some kind of an example. So can we make sure our free software comes from the sources we were set, right? Imagine that we want to download some free software program. We can, I don't know, whatever you like, whatever program you prefer, like I don't know, LibreOffice, right? If I want to download LibreOffice, the LibreOffice team is telling me that LibreOffice is free, right? It's a free software project. So if I go to the website and I download the binaries, I'm supposing that is true, and I'm downloading like a free software project. And also there's another website or I don't know, a tar GC in the internet that is giving me the sources of that LibreOffice. But I can't really make sure, or can I, right? That source code corresponds to the binary I downloaded, right? Is that possible? The answer is no. There's no way to know that. Why? Mostly because the binaries I download, they are a result of the compilation of my program. So if I'm compiling these sources, they are going to give me some kind of binaries, and that's the result of my compilation. The problem here is that we have several issues in between. first of all, we don't have the same machine or the same setup that the person that compiled this had. So we are probably, if we compile the software ourselves, we are probably going to obtain a different result that person obtained in a binary level, right? The binaries, the files are going to be slightly different. Most of them might be the same, but some parts might be slightly different because of some differences in the environment, the setup, your computer being different, the architecture your computer has, the time when this was run, whatever, right? That's one of the points. And in Guix, we are already protecting us against this using the reproducible builds concept. So we are going to, with Guix, we are reproducing the environment where the compilation was done in the first place. So when we try to compile things in our computer, the result should be the same. That's the first of the points. The second point is that we don't know if the person that was compiling this software for us, or the program that was compiling this software for us, is tricking us into thinking that the source they used is the one that they really used. So imagine we are downloading like LibreOffice that I told you before, but the person that compiled that LibreOffice used the code of Microsoft Word, and then when we download the thing, we are downloading Microsoft Word. But they were telling us, this is LibreOffice. This is LibreOffice. I compiled it from the source code of LibreOffice. That could happen, and we don't have any way to know this because the compilation process is not reversible at 100%. It's kind of reversible. We can reverse some things, and it's really, really hard to do. But we can't really, really reverse everything and match the original source code of the process. So no, we don't have a proper way to know if the source code we downloaded from the internet matches the code of the application we downloaded, the binary application we downloaded, and we don't have a proper way to know that specifically those were coming from the same place, or let's say in another way, that the binary we have is coming from the sources we downloaded, or the sources we were promised to be in use for this code, right? So this is a very big problem. And also pay attention to the fact that I differentiated, like I made a very big difference between the person that is compiling the software, because in the end there's a person behind, and the program that is compiling the software. We have two options here. The person is a malicious person that is trying to replace the source code with something else and compiling that. And we may have a malicious program that is doing that behind the knowledge of this person, right? Maybe the person is using the correct sources. Maybe the person is trying to do their best. But is the compiler that is a corrupt program, and that's tricking the person into thinking that this process was correct, but in fact it's introducing malicious functionalities in the binaries. So this is a big issue too, because we don't really know how the compilers are built because of the same bootstrapping problem. The compilers are also compiled by other software, so we can't really know where did the compiler source code came from, like what did it come from, right? So if we continue this chain, the compiler that compiled the compiler, we also cannot know where did the software that made this come from, right? And we don't know if the compiler that compiled this was a correct compiler. If we continue to do so, we are probably going to reach a point that makes us think, like, where are the compilers coming from, right? That's the main issue we're dealing with here. So yeah, as I said, the compilers, being the compiler a person or a program, they might be evil, and they might be introducing weird functionalities. So I introduced you a couple of talks there. One is from 2020, is a talk by my colleague Janneke, talking about this specific issue, the bootstrapping, and how he started working in the bootstrapping problem. And it's very well explained because he says literally this same metaphor, and it's a very good one, saying like, in order to make yogurt, you need milk and yogurt. So you mix the yogurt with milk, you put it in some kind of a hot place, and kind of not very hot, but some kind of a hot place, and tomorrow you have yogurt. So you can make more yogurt now. But the question is, where did you get the yogurt from? Well, someone took some yogurt, put that on milk, and obtained yogurt. And this is a pretty interesting process because you don't really know, right? And this is the same that happens with the compilers. So you have some software, some source code, right? You compile it, you have a binary. Yes, and where do you get the compiler from? So you get the compiler source code, you compile it, and you got your compiler. And where did you get the compiler from? So you continue to do so. So all this problem is a very interesting problem, but it's even more interesting if we mix it with a trust-in, trust attack. In there you have a paper. There's a link in the second footnote that is going to show you a possible attack that Ken Thompson, one of the authors of Unix, described when he got the ACM award. So, yeah, what is this attack? So this attack is a definition of a compiler that is corrupt. It's a, let's say, kind of a malicious compiler that is able to know if the output program it's outputting is a normal program or another compiler. If it is in a normal program, it's going to introduce some kind of a vulnerability or malicious code in this output program. If the output is another compiler, it's going to copy this behavior. So this second compiler is going to be the same. It's going to be infected by the same idea. It's going to be able to know if the next program is a compiler or not, and in that case, it's going to do accordingly, right? So this is a very big issue because imagine that the first compiler we are using for all this, the first compiler in the chain, the first yogurt in these yogurt generations, right? In all these yogurt generations, this yogurt was a malicious compiler described in this paper. So if it was something like that, all the programs generated with this compiler will be like malicious or have some vulnerability that is going to be a problem for us, potentially. But all the compilers obtained from that are going to be also malicious. So all the newer compilers coming from that old compiler are going to be malicious too. And as we already said, we don't really have a way to make sure that didn't happen. So all the compilers we are using today might be under this attack right now, and we couldn't know. There's no way to know it. So this is the problem we are trying to fix. So the bootstrapping problem is this, and we are trying to, with this bootstrapping effort, we are trying to fix this issue. Fix the issue how? What does it mean, fix the issue? So the main problem of this chain is that we are not able to know, we are not able to match the source code to the binary. What may happen if we actually make a compiler that doesn't have a compilation step, that is just the source code? If we are able to do that, we could compile the next compiler, making sure that the compiler is not a source of possible malicious behavior. If we were able to do that, we will compile the next one, making sure that the compilation process is not potentially corrupt either. And we will continue to do so until we build all the programs in all of our systems, right? So in Guix, we are working on this. It's not me, the only one that is working on this. We have been working on this for long, even before I was taking part in Guix. This was something that was worrying some people in the Guix community, and they were working on this. And they found a way for the x86 architecture for 32 bits, which is kind of an old architecture, but is compatible with the newer computers, so that's fine. They found a way to make all this process or at least most of this process, to avoid having to rely in any compiler, to avoid having to trust anyone. And that's a fundamental thing in free software. When we talk about free software, most of the times we don't talk about trust. We are not trusting the people that makes the software. That's why we like free software, because we can check. We don't need to blindly trust a company or a person. We can literally go to the source code and check. We don't believe them, and they don't want us to believe. They want us to go and be critical and check. And the bootstrapping problem is literally undermining that, because even if we can download the sources, as we can't really match the source code to the binary, checking doesn't make any sense, really. So this bootstrapping effort is going to fix kind of fix this issue, because we don't have to trust the compiler, not the person, not even the program, and we can really know all the chain of programs we built came from source code, and if we want, we can audit everything from the early beginning to the end, to the final Linux distribution, in our case, Guix. So, yeah, now the thing is the following. Can we trust the kernel that is running our machine? Can we trust the machine itself? That's a very good question. And in the end, the work we are doing in RISC-V, as I already told you, it's an open architecture. We are doing all of this because we prefer not to trust anything, right? Not even the chip where we are running. So this work of the bootstrapping effort for RISC-V is potentially going to fix this issue. We shouldn't need to trust the processor even, right? Or even the processor in the future. And that's why I'm interested in this problem. And that's why we are making a lot of efforts to make this happen. So now we can announce properly that we are working in a new commencement file, and I made most of it. And now I know that Ephraim is working on it. And we are hopefully going to integrate it in Guix soonish, because it's a lot of work. But I wrote a very prototype-like version of the GNU packages commencement module that is able to bootstrap a RISC-V version of Guix from source. You have probably already read something about it in the Guix blog. You can find some blog posts about it, not from me, but the effort that Janneke and other people did in the past for the bootstrapping process for x86, and you can read about those. They are super interesting and they are very well written, and they explain how Guix in the beginning was relying in very big binary blobs, and nowadays it doesn't rely on so many binary blobs, and it's relying mostly on source. That's that effort is called the full source bootstrap, because we start from the early beginning from source code. But in fact, in Guix, we are also relying on Guix being installed in the machine and these kind of things. And that's not really source. There are some people working on these kind of projects where they really want to start from source. They don't even rely on the Linux kernel being in the machine. They are working on making all this run on top of UEFI, which is some kind of firmware we have in the motherboards. And yeah, there are many people working on this kind of work. Not so many, but there are some people, let's say, working on this effort, trying to make the commencement process or the bootstrapping process work properly. The prototype thing that I did is super simple. We have most of the packages are being bootstrapped, like the ones we need, but some of them are not bootstrapped yet, and they will need some packaging work. And I'm not very good at that. I know we are in a Guix event, right? I should be talking like I'm the best with Guix and stuff, but I have to admit that I still have issues. I'm better at reading other kind of systems, and it's really, in the work we have been doing, I have to admit, it's really frustrating, because some of the packages we are including in the commencement module, they are very old, and their build systems are not designed for what we are doing with them, and we have to play around many things, and it's really energy draining. That's, I have to admit. So we have most of it done for RISC-V. The commencement is really different to the one that we have in Guix currently. So the process of integrating that in RISC-V is going to take some time. But we changed very interesting things in the new commencement module, And this is probably going to allow us to make commencement modules for other architectures that we have been having trouble with. So let's talk a little bit about that. So in this process, we had to make many ports. What is a port? What does making a port mean? So some software is designed for a specific architecture. You can think about a compiler, right? The compiler needs to create code that is runnable in some specific architecture, in some specific device. If the instruction set architecture of that processor is different, the code doesn't work. If I try to install like an ARM binary in my x86 machine, it doesn't work. If I try to run it, the instruction set is not matched, so it doesn't work. Literally, the computer does not understand the binary, right? And that's pretty normal. That makes a lot of sense. So in the commencement process we made for Guix and also other distributions we are going to talk about later, we had many programs that were only for x86 because mostly, let's say it plainly, RISC-V was invented after these programs were done, literally. So we need to port many things. So Stage 0 is one of these initial projects we use in the bootstrapping process, and this is super interesting. Is where everything begins. Is a set of compilers that they don't need a compilation step. So we start with a very simple assembly file. With that, we make some assembler. We start assembling bigger and bigger programs. It's really hard to explain, honestly. We make bigger programs, and in the end, we have a kind of a C compiler. And with that, we start building other kind of programs. So this Stage 0 POSIX project, was already available for x86 and other architectures, but it wasn't available for RISC-V. I have to say, I didn't do this job. I only made some very, very small part of this job, super small, and most of it was done by my colleague Andrius Stigonas. So GNU-MES is one of all these other very interesting projects in our chain, and it's super important. It's a couple of programs in the end. It's a C compiler written in Scheme and a Scheme interpreter written in C, and they are like mutually hosted. One can compile the other or interpret the other, right? And this is super cool. This was done by Janneke, who is a Guix contributor and probably, I think, a committer too. And he's the one that is pushing mostly this bootstrapping effort in Guix. So thanks to Janneke. So this project was started by him, and I think it was Vonderland. I don't remember the name, but this is the surname. This guy ported all GNU-MES to RISC-V, and it's super cool the work he did. So thank you for him too, because without this work, this effort from the last years would be probably impossible. So GNU-MES was not supporting RISC-V architecture yet, so support was done. TinyCC too. TinyCC is one of the early compilers we use in the chain after GNU-MES, and this compiler needs also some RISC-V support in order to be able to run in and make programs for RISC-V. And this was ported by the TinyCC community from their set of developers, but we have to say the port wasn't perfect yet. We had some functionalities that they were left, and some of this work was done by me, some of it, only some, and by other people that was collaborating with us. So some backports now. This is ports, is meaning that we have our program, we are adding some functionalities to our program in order to support a new architecture. What is a backport then? So a backport is when this happens to the past. You remember this Zelda game, A Link to the Past, or something like that? So this has been my life for the last few years. So GCC 4.6.4. What can I tell you about this? Right. This GCC is a very old GCC. It's like 10 or 12, or I don't remember how many years old. But we need it in the bootstrapping chain, because how do you build a modern GCC? You need a C compiler to build GCC. And GCC is huge, right? The code base is horribly large. So it needs a very good C compiler to be built. So the modern versions of GCC the last one, like, well, let's say the first one supporting RISC-V was 7.5, and we needed something that was able to build that 7.5. The only thing we found that was able to do that was GCC 4.6.4, well, on other versions in this line, right? So I had to backport the RISC-V support to a GCC that was written before RISC-V was even invented. And I took all the modern code of GCC, of the version 7.5, and I inserted that in this old version of GCC. The funny part comes when the modern GCCs are written in C++, and this GCC was written in C. This is why we needed a proper C compiler, C and C++ compiler, because the modern versions of GCC, they require not only a C, but a C++ compiler. So, a very big chunk of the work we have been doing in this is backporting this support to an older version of GCC that is not maintained even, but we need it in order to build the newer versions of GCC. Why? Because we are starting from source, right? Remember the first of the issues. We have small compilers, small C compilers. We are building from source. Then we compile even more complex compilers until we can reach some powerful compiler like GCC, in this case 4.6.4, and with that we build a C++, well, this is a C++ compiler. We build GCC 7.5, which is written in C++, and with that we have a pretty modern GCC that can build many programs, and then we start to build mostly the world, right? This is the process we are following. So also in between, in the middle of this chain of programs that one builds the next one, we have a bootstrappable version of TinyCC that was forked by Janneke in the past, that is a simplified version of TinyCC. Why do we need a simplified version of TinyCC? That's probably you are asking yourselves, right? Because we need to be able to build it with a simpler compiler, a very simple compiler. So for that, we have to also to backport it. This very simple version of TinyCC was forked long time ago, several years ago, and it didn't have the support that the community did for TinyCC. I'm talking about RISC-V. So I spent some time backporting this support for TinyCC. So this was some work I did, not this year, but the year before and the one before that. So it's been a very long process, and I've been mostly working on these two issues, but with help from other people, some of the TinyCC contributors, and also my colleagues like Janneke and Andrius Stigonas too. So that being backported and ported, we had all the pieces we needed to construct the full chain of programs that one can compile the next. We also needed to change some other things and stuff, but the chain that we had in x86 was not available for us in RISC-V. Why? Mostly because of two main reasons. In the chain we were using also another old version of GCC that was the 2.95, something like that. Is super old, and I was too tired to start backporting to that version, and it's probably going to be a lot of work and very difficult. So we decided to remove it from the chain, mostly because TinyCC says, or they claim, they are able to compile directly GCC 4, and so we tried that and it works, and we demonstrated it works. So good thing, good for TinyCC developers. Also, we realized the older versions of the glibc, the C standard library, doesn't support RISC-V, and we didn't have any good compiler that was able to compile a pretty modern or a modern enough glibc that had RISC-V support. So what did we do? We removed GCC 2.95 from the commencement module, we removed glibc from the beginning of the bootstrapping process, and we started to use Muscle instead. This carries a couple of issues that are very related with Guix, which is the thing we are dealing with, right? In Guix, we hope that we will be able to support the hard, and Muscle is just for Linux. And this is a problem right now, but in any case, the bootstrapping process doesn't work for the hard, as far as I know. And the hard doesn't have support for RISC-V either, so why even bother at this point? So we tried to do this because it was the best effort we could do. We wanted to have a bootstrapping path, But at the same time, we know this is just a temporary solution, and probably in the mid or long term, we have to do something about it. But we will think about it when we have to, right? At the moment, it's better to deliver something to the people, and then we will make decisions on top of it. So if you want to see if this process is being integrated or not, you can go check this issue number 71921. This is the issue number where everything is being tracked, or better said, where I put I passed all the work to Ephraim, who is the Guix maintainer, or one of the Guix maintainers, as you already know. So he's working on integrating all this work we did in Guix also. So there have been other efforts too, like to convert my commencement module to x86. That's done by Janek in the moment. He's working on that. And there are a lot of people in this process. So let's talk about the people, right? First of all, I want to thank my colleague, Andrius Stikonas, for the work he did. This is not his name. This is the nickname he has in IRC, the name he has in IRC. And I have to thank him because most of the work, it was impossible to do by my own. I started working on this project on my own, backporting compiles and stuff, and I was completely depressed. I felt super alone. I didn't have anyone to talk to, and his knowledge of the area, it was fantastic. He helped me a lot in this second effort we did to make the final bootstrapping chain. He's a great guy. Helped me a lot during all the sleepless nights we have together. And yeah, I'm super thankful for having this colleague working with me and not being working alone. Also, I have to thank Janneke for making GNU-mess, making all these efforts in the bootstrapping in Guix, and the help, because he's also helping a lot, helping us understand GNU-mess and taking part in the development of the standard library we have inside of Mesh, and helping us to understand, make the tests, get all the patches we send to him, be super helpful with them. So thank you, Janneke, too. And Ephraim, I have to thank Ephraim because mostly, and I did all this work, and now all his problem now. So thanks, Ephraim, for helping me making the packages, because this is something that packaging complex software is kind of hard to me, and probably hard for everyone. So thank you, Ephraim, because he has all the knowledge of making the packages, all the Guix knowledge we need, and he accepted to start integrating this on Guix in the future, and also all the work he did already on RISC-V support for the full Guix, right? So also for the money, I have to thank NLNet and the NGI funds. This whole effort was funded by NLNet. They literally paid me money in order to make this, but they also give me enough money to be able to pay some other people, like the ones that I already mentioned. We didn't have tons of money, but we did our best to pay everyone with some respect to the work they did. Also, we have to thank them because they have been funding this effort for years. They have been funding GNU-mess. They have been funding my previous effort that I was working alone. They funded that too. And many other projects related with this. So we have to thank them, because without them, this would be impossible, because the amount of work we have to do is so much. We probably wouldn't be able to do it by ourselves alone and with no money. So yeah, this is super important. It sounds stupid. It sounds like, yes, of course you need money. Yes, of course you need money. But when you are trying to develop free software, most of the times there's nobody really wanting to invest on that and pay you money for making it. Like, they consider it has to be done, right? Someone has to do it, and it's not that simple. It's not that simple. So people need to work, people need to have free time, and these kind of projects like NLNet or these kind of people, like, they invest on having a good software architecture, a good software infrastructure, and that's super important for the free software world. So big up to NLNet and the NGI funds. This is funded, most of it, from the European Union. So yeah, thank you. And yeah, I want to stop this a little bit to talk about the leadership. You already know, if you came to my other talks I gave in the past, you know, I always try to put some kind of a personal background on things, or an emotional background on things. And in the end, most of the times, and I want to share this because I think this is one of the Guix, the best things of Guix too, and it's the leadership. I don't want to talk about me in the first place, but I'm going to go back to me. So in Guix, what we have is a very, very interesting leadership model where specifically the author of Guix, Ludovic, it's a fantastic way of leading the way he does it, right? He's a very human person. He's very near to the developers. You can talk to him. It's very easy to reach him. He's not like imposing things. He tries to work with other people, be human, be empathetic, and that's for me the perfect model of leadership. He's also technically super competent. It's great. The way he does it is fantastic. Obviously, I'm not the same person, but I try to learn from the people that is giving me a good reference, and I try to do it in a similar way, but of course my personal abilities are a little bit different. I have other good points and other bad points that he does. So he's a very good inspiration, and I'm really happy to find him, like meet him in person and talk to him, because it's really, really cool to have people like that. And I have to say this talk I'm giving right now and all this is a similar effort done from my side to try to push the people that deserves the attention. And I don't really consider I deserve the attention myself, but also in this project, in the bootstrapping process, what I was feeling in the last years and since I started working on it, is that it's a project that is mostly overlooked by people. We don't really consider this is a problem. Many people don't even understand what's going on. And the most important part is we don't know who is working on this, and we don't know what kind of work they are doing. And this work is hard, man. This thing is super difficult to achieve. And there's a lot of people working very, very hard, like all the ones that I mentioned, but many others too, that they started several other projects to try to bring this bootstrapping solution to Linux distributions, not only in ours, the Guix, but others like Live Bootstrap. Also, there's Jeremiah Orions that started the Stage Zero project, and several others. Fossey out there. There's many people working on this. And as the project, I guess it's difficult to understand, or maybe it's not very popular because it doesn't really bring you anything as a user. If you just think on user experience, it doesn't really change that much if you just think on the surface. So I want to take this time, and this is the goal of this, or proposing talking with you, all of you that are listening today, to pay attention to all these people that was working in these kind of things that I didn't know of a couple of years ago, and they are making a huge effort. So don't pay attention to me. I'm just a random dude that got into this. I don't know how. I guess also this is that a leader pushed me to do, right? Which is Piotr. Piotr pushed me a little bit to get into this project, and I accepted, and I accept the responsibility I've been given during these years, because I was the one that was asking to NLN for the money and being the responsible person behind of this. So I accept it, and I like being the kind of let's say the responsible person behind this. But I don't want to focus the attention on me, but in all these people that was giving all their free time mostly for free until we had some money to be able to pay them. And they were doing it because they consider the problem interesting, because they like it, and because they like you as a person, because they want to fix your computing. So thank you for them. So in the end, just a couple of things I did with my leadership abilities. I wrote everything in my blog. I gave an introductory talk about this in FOSDEM a couple of years ago, or 1 year ago, 1.5. In 2023, and I also did another talk in FOSDEM in 2024 in person. So you can go and read what's the one in 2023, because I explained the problem in more detail. And in 2024, it's just a technical talk that is interesting, because I say stupid things, I make jokes and stuff, but most of it is just technical background that it may be interesting to see the internal ports, or which compiler builds which compiler. So if you want to watch it, I'm happy to to share these talks. And if you have any question, of course, I will answer. So send me an email or whatever. So in summary, thank you for the help to all the people that helped in this, because this is a huge effort. It's not just my effort. It's huge. I only made this small piece that is RISC-V, and without all the work that was already done, this would have been impossible. I want to thank for the money. Of course, the money is important. I want to thank also people who supported me during this process. Also, not only me, but supported us, because I guess all of us needed some support, because this is mentally exhausting. And also, I want to thank you for the attention you are giving me, and also for the questions that I guess they are going to come in tons, not only now, but also in my email during the next days or probably weeks. So thank you in the end for everything.
Stop video. There we are. And now you should be able to.
Okay. Do you want me to answer the question, Steve?
Yes, please. Yeah.
Okay,
So let me just say, the reason I was sort of asking was I was really interested in what sort of hardware you started with, because I guess you started a while when there was less hardware available, and I'm also kind of interested in what kind of hardware is available now for people going forward.
Okay, so when we started this project, or when I started this, I made everything like in a virtual machine, everything, and that had several issues. So when we started this second effort, that was finally to work in the commencement module, we bought some hardware, and we bought some Vision 5, I think that's the name, Vision 5 boards. I don't remember how much they were, but they were like less than $100, something like that. And they are not very powerful. They are as more or less like a Raspberry Pi machine. I am aware that there are some other machines out there in the wild you can buy, but most of them are in that level of how can I say, of performance, right? It's kind of a Raspberry Pi, not more than that. So yeah, there's some hardware out there, but it's not very performant, and it's not like a desktop computer. I know there are some desktop computers you can buy, but I wouldn't expect to have a very powerful CPU in them. Does that answer your question, Steve?
Yeah, so and did the hardware availability or the sort of non-performant hardware make the bootstrapping hard? Like, what was the sort of impact on trying to do the work?
Yes, it was. Yeah, how can I say? In my computer, in this current computer I'm using right now, which is an x86-64 computer, an i7 from like 4 years ago, the whole bootstrapping process in an emulated version, it took like a couple of days to run, or well, not a couple of days, like one day. What I was running it during the nights, so I was running it like before going to bed, and in the next morning I had the result. Yeah, it was like 12 hours, something like that. Yes, just to reach a GCC, right? In the hardware we had, in the real hardware, it took like 7 days or something like that. It depends on the run and stuff. So yeah, they are not very powerful, and we know some of the issues we have in this process and why they are not very fast. The main issue is that some of the compilers we were using in the early stages, they are very reliant on memory access. In this case, MES is going to use a lot of memory because it is written in a scheme, so it's going to attack the memory that is fragmented. I can get into the details, but it doesn't really matter. So the idea is that these devices, the memory access they have is not very optimized. So these steps were taking way longer than in our machines, right? And then after that, GCC was kind of okay, but this early process of the bootstrapping took days, and that was very slow. And if we wanted to test things, we needed several days to know if we are going to have a result, a proper result, or an error in the middle. And that was somehow delaying the work a lot, and the wait times for having some feedback were very long. That was pretty frustrating, and that there's nothing we can do at this point. So the solution was using emulation, but also the emulation is not great because in QEMU there is a problem. Yes, there's a segfault something appearing or something like that appearing randomly. So we had a lot of issues between these two things.
You basically bootstrapped like they did when they were using mainframes. You did your work during the day and then you went to bed and waited for the result.
Yes, literally, that was what we were doing. Yes, exactly.
Cool. All right. Thanks.
Okay, there's another question there by Fabio. Do you want to say it out loud, Fabio?
Sure. Yeah, just if you were aware of any previous or current attempt at doing anything like this, maybe as part of a different platform, something on a tail, like around unikernels. I don't know.
We have been working very closely with one of the persons I mentioned, Andrew Stikonas. He's working on something called Live Bootstrap, and this is also kind of a bootstrapped Linux distribution, let's say. And the way they do it is very different to us because they don't rely on Guix or anything like that. They start from how can I say, from simple bash scripts or something like that, or shell scripts that are written in another language they have. That's very similar to our case. So we were working together mostly because Andrews has a lot of knowledge about this because he has been working in this project for a long time. And in fact, we reached the bootstrapping step earlier in Live Bootstrap because the system was very well prepared for testing things. In our case, in Guix, it took a little bit longer. The packaging is a little bit more difficult. And they already had in Live Bootstrap, they already had a lot of scripts to do it faster. So about Nix and another systems, I'm not sure about it. I think Nix is also interested in bootstrapping things, but I think they started in TinyCC or there was some effort about that. So they were starting way farther. We start in stage 0, which is almost source. But I do know that they are interested on bootstrapping Nix. About the rest, I'm not really into this. How can I say? I'm not really interested in systems, so I took this job and I do it. And I mean, the state of the art, I don't know that much about it. So yeah, I can't tell you more. But yes, if you take a look into Live Bootstrap, that's a very interesting project where you can see many things.
Thank you, Ekaitz. Yeah, that's very clear. Awesome.
Any more questions?
I might have another one, a little bit along the lines of the previous one. If you have seen interest from academic institutions, research groups, if you had the chance to collaborate with any university, for example, or or you have heard of any theoretical research around this.
Yes, not really about bootstrapping, but the person that pushed me to enter this world was Piotr Prince. He's working at university. You already know the guy. He is one of the organizers of the Guix Days. So he's working with I think it's the University of Cornell in the USA. They are making a very interesting setup of a huge CPU with millions of RISC-V cores, something like that, something super crazy. And they are very interested in the bootstrapping process, and they are also making the chips. They are making the programming languages to run on top of them. They are making the whole thing for some bioinformatics things like DNA sequencing and these kind of things. So they are interested on that, and me and also Arun and some other people that might be with us at this point, at this moment, we collaborated with them a little bit. We talked with them and we prepared some papers and stuff, but for presentations about the work they are doing with Guix. So yes, they're interested in the bootstrapping, but in a more kind of like more as a tool than as the research goal, let's say.
Okay, very clear. Thank you again, Ekaitz. Anyone else?
I've got one more question. So you sort of were saying that you've handed the the next stage over to Ephraim, who's going to work on sort of integrating it. What's the sort of next stage for you? Is there more RISC-V work to be done, or is this kind of the end of this piece of work? You know, bootstrapping. I'm not saying it's done, but you know what I mean. Like it's done for you, and then you're going to move on to something else. What's the sort of direction of travel? More RISC-V bootstrapping or something else?
To be honest, I'm super tired of this work. This is very exhausting, but I'm this kind of people that can't stop working. So I have some other ideas in mind. The next thing is that I ask for more money to NLNet for improving the mesh interpreter. So it's not going to be specific for RISC-V, but improving mesh speed. I don't know if they are going to give me the project, but the idea is the following. I want to improve the speed of the mesh interpreter, which is running one of the early C compilers we have in the chain. If we improve that speed, the response times, let's say, of the bootstrapping process will be possibly faster. So the feedback loop can be shorter. So the next improvements on the chain, they will be easier to achieve. So that's part of my interest in the future. At the moment, I just handed this to Ephraim. I will help him, of course, with anything he needs to try to integrate it in Guix. This is going to take probably a long time. And also will help anyone that is trying to take my commencement module or the one we integrate to convert it properly to x86, so we only have one commencement and not several commencements as we have right now. So I'm going to be there trying to help people, but I'm not really focusing in RISC-V right now, and I will try to push a little bit more on mesh interpreters speed. That's a little bit the goal.
And that's something that would help then across all architectures, but potentially.
Yes, and mostly in RISC-V more, because as we don't have very powerful hardware to run on, the memory bottleneck is really killing us. It's like the longer wait times are between mesh and TinyCC. That's taking days to build, and if we improve that, we can reduce it to I don't know, maybe 1 day only instead of 4 days or 2 days or whatever. So that could be specifically very good for the RISC-V case, but it will improve all the other architectures too.
Got it. Cool. Thank you.
Yep.
Ekaitz, you mentioned NLNet a few times, and of course I understand generally positively for their help, their support, and everything. Is there, of course, this goes beyond the bootstrap problem, but is there anything that you want to share about the how to apply for an NLNet grant? If the process was easy, any suggestion? Maybe someone could be interested.
Yeah, I can share my experience about that. I first made a proposal. The first proposal was rejected. Probably, I don't know, because let's be honest. 2 years ago, nobody knew me. Like I was like a random dude in his sofa trying to code some things. So the first proposal was rejected. I made another proposal again with some help by Piotr and some other people that helped me to write something down that was appealing for them, and they took it for the next level. The next step is to describe a set of tasks. The first step is very easy. Just describe your project and what are you bringing to the table. It's very easy to write down, but you have to be very aware that the money you are asking for has to be fair. So if you do it fairly, it's probably going to pass the first round. So the first suggestion is not to I don't know how to say, don't give up. Just if they don't accept it once, there will be another call for new proposals, and you can do it again, and it works. So I did it again, and I passed to the second round. The second round is simply, well, it's not very simple, but you have just to describe your tasks in pieces and say how much do you want to be paid for each of the tasks. You have to be as specific as possible. If you are very, very specific, it's likely to be approved. If you are not specific, they don't like that, and it makes perfect sense. So they have to be very practical. And I did that, and they gave me the money. Simple. It's not a lot of money, but it's enough for living, specifically here. Maybe if you are living in, like you are in London, probably life is going to be more expensive. But yes, they are very, very technical people too. You can be as technical as you want. They're going to understand it. And if they don't, they will ask you, and they ask very good questions. So they are technical people. Don't be afraid of, like, I have to sell my thing. No, you don't have to sell it. You just have to tell what are you doing and why is this interesting, and they will understand. And then you have a meeting with them, and they say yes or no according to the money they have available or the impact your project is going to have. Then the work is very easy. When you are in, you do the task, you get the money. As simple as that. So it's really, really cool to work with them, because you don't have to justify stupid things. You don't have to sell yourself. You don't have to do that. This is very, very good for technical people. Like, they understand the technical needs of technical people, and they don't care if you are good at selling yourself or explaining things. No, go technical and they will understand. So that's very good if you want to, how can I say, if you're a very technical person. And as I am that, I'm not very, very, very good at selling. I can do my best, but I'm not good at that. And you don't have to be. So it's great. It's great. I don't know what's the status of the money right now in the European Union. I know we are having some issues about some funding being cut for the next years. I'm not sure about that. But as long as they continue to do what they are doing, this is a very good opportunity for free software developers. Of course, the maximum amount of money you can ask for a project for an individual is 50K. 50K can be not that much, depending on the country or in the city you are living. So you have to be aware of that. But the rest of the thing is for a technical person is fantastic, the way they are dealing with it.
Sounds great. I like the idea of the no nonsense approach. Very practical,
simple,
and technical. Yeah. Thank you.
Yeah, we have another question there in the chat regarding NLNet. Do they support only if you are residing in the EU or anywhere in the world and living in South Africa? Interesting question. I'm not sure about that. I'm not working for NLNet, so I don't know. You should ask. The point of NLNet is they are using European money. So mostly they accept any project that is going to bring something good for the European people. It doesn't matter if you're living in South Africa, in principle, I think. So if you are bringing something good for the whole world, that's tangentially helping European people, so that should be okay for them. I know some people from the United States that they have NLNet grants too, but I don't know if that, like, United States is a special case or not. So you should take a look into that. But they are super happy to tell you if it's possible or not, and you can find in the website more information about that. Any other question? Okay, no problem. Thank you for the question. Also, I'm very happy to answer questions about other things that are not directly related with the bootstrapping. Okay, looks like we don't have more questions, guys.
I think you covered them all during your talk. That's why the
yeah,
talk was so
surely,
good,
surely.
and you did such a good job on the quality of the talk that I think you covered it all.
Yeah, I just want to say one thing, that we have Andreas here. When I gave my FOSDEM talk, Andreas wrote me an email and offered me help. So I just want to thank you, Andreas, publicly, that he was interested on helping and he lent a hand, even if I didn't need it. So thank you, Andreas. Yes, just to say that you are here, just to publicly say that you have been a nice guy to me, even if you didn't know me. So thank you. So that's all for my part, I guess, right?
Yeah.
Yeah, see you next time, guys. Thank you for giving me this space.
Brilliant.
Thank you, Ekaitz. It was great.
Bye-bye. See ya.
All right, everyone. Thanks very much. We will be back together as a group in a few weeks. At the moment, we don't have any new talks, but we are trying to calendar further talks into the autumn. So if you have an idea for a talk, whether you would like one that is long or short, whatever topic it's about, if it's at the expert level or the entry level, we'd love to hear a whole range of different things, which are geek, scheme, bootstrapping, security, whatever your interest is. So if you've got an idea for a talk, please give Fabio or I a shout, because we'd love to have further talks. All right, everyone. In that case, have a fantastic rest of the evening, and see you next time. Cheers, everyone. Bye-bye.